Hello and welcome to TidyX, a screencast where we go through and explain code. I'm Ellis Hughes. I am a statistical programmer at Fred Hutch Cancer Research Center.
And I'm Patrick Ward, and I do data analysis in sport. And if you're interested or have questions about some of the things that you see or other bits of code that you've come across during the Tidy Tuesday project tweets, feel free to ping us at tidy.explained, tidy.explained@gmail.com.
All right. So this week's Tidy Tuesday data set is actually a pretty fun one. So they took BBC did some ranking of some music, and they aggregated all that together for us and made it available for people to be analyzing and showing it off. So they also scraped some Spotify information off the Spotify API using an R package and brought it all together this week into two data sets. So we've got the polls.csv and rankings.csv. And so there are, as always, some pretty ingenious submissions. But one that we saw this week that we thought would be, that our viewers might think is interesting, is from Priya Shukla, where she generated this Lollipop chart of 3 different time points across the entire data set that they showed, where she annotated it with, all right, so this is when she was born, this is when she turned 16, and then this current year when she turned 30, and it going over the top rap artist rankings during each of those years. So we thought this was a great way to show how data can be viewed in different ways, but it also just looks really crisp.
Yeah,
it was just something that we really wanted to touch on because we haven't really done that much yet, is explaining how to make your plots look really nice.
Yeah, I think this is also really cool because it's a music theme, and being a guitar player, like when I look at this, it looks like a fretboard. So I think it's such a cool play on the plot with the actual topic, the content of the topic. I think it's pretty cool looking.
Exactly.
Yeah.
So she very kindly shared her code on GitHub, so we can view that here. So we took this code and copied it into our session here. So we've got this available for us. So we're going to now go through and explain each step. All right, so at the very top here, she's loading in her libraries, which is, very good practice to have up front which libraries you're going to be using. But here she did something unique, which I don't believe we've seen yet, which is where she separated out the libraries that she's initially loading in from some other steps that she's performing and annotating them with hashtag word cloud packages, which is, telling us immediately that these are used for the word clouds that she does a little bit later on, where we actually covered word clouds in episode 2. So if you want to learn more about word clouds, go there. But let's get started with loading in her libraries. All right. So I'm running an old version of R apparently, so need to work on updating that. All right, so this first step here, she is reading in the data. It looks like she copied that out of the Tidy Tuesday section here, because you can see some code here referencing my R package, Tidy Tuesday R. Either way, it's whatever's easiest to bring in the data for her. All right, this step here, she's taking a quick look at the data set. So she's doing as data frame on polls, because polls is a tibble. And so tibbles have actually a really unique printing mechanism compared to the standard data frame that exists in base R. And so what it does is it limits the number of columns that it'll print out to be based on the width of your viewing table or console width. So if we make that a little bit smaller and we print polls again, see how, did it?
You got to make it even. I think you got to make it even smaller.
All right, let's make it really small. All right.
Yeah.
So now when we run polls, see how it shows that there's critic country and critic country 2 where it didn't print it out. And so that's because it's trying to optimize the viewing ability of our tibble. Additionally, it'll only show the first 10 rows by default, which is different from data frames, which will show by default, I believe it's the first 1,000 rows. And so this this is an easy way. Tables have this nice printing mechanism, but if you want to see all of them, a really quick way to do that is just do as data frame, and it'll print it all out for you.
A cleaner way of doing it is to actually use the view function, because it'll just open a second window there for you, and you'll be able to see. And that's much nicer, and it'll also keep the headers. So as you scroll, it'll keep the headers constant or fixed, so you can see all your data. You can also move columns, so you can shrink the title column, for example, which looks exactly just like that. So
you can also do some reordering with these.
Yeah.
So,
If I was going to look at a full data set, this is usually the way that I prefer to do it.
All right.
Cool.
So then she does a glimpse too. I guess decided after she printed off the as.data frame that was a little bit too large. So glimpse is another very quick way to view your data. It quickly summarizes what's going on here, and so in this case, it's showing us what is the title, what is the type. So each column is going to have a type, and then it previews a number of the entries for us. So this is also a great way to view your data here. So you can see like rank number 1, Terminator X to the Edge of Panic by Public Enemy, gender male, written 1998, and this is the Critic. So it's just a nice way to view it all. All right, so then here, what she does is she's sending polls into this filter function, which removes all the cases where this expression is not true. And so what she's doing is she's trying to keep all the cases where year is equal to 1989. So she annotates that with this comment here. So 1989 appears to be the year that she was born. So we've subset that data set. She does a quick glimpse as well. Not a huge difference. I mean, there's just a lot less, artists here.
Only 16 rows of data in 1989, it looks like.
Yeah.
So,
all right. Yeah. So then she throws it into a ggplot 2, and this is where she creates her lollipop plot, which is what we thought was really interesting here. So in her ggplot, when she creates it, she's defining her data set to be polls 89. Then she sets the aesthetics at the very beginning. So this means that she doesn't have to go back through her other layers of ggplot2 and in her ggplot and then define it. So she's defining her x-axis as the artist, and then the y-axis is the rank of that artist.
Mm-hmm.
She's then creating this geom segment. So that's creating the stick of the lollipop, where geom segments have a slightly different aesthetic than most aesthetics you might be accustomed to, which would be like geom call, geom point, geom line, where she has to define what the X start and X end are, as well as the Y start and Y end. So this is allowing you to basically draw a line between two different points in your ggplot, regardless of where. So you can just shape it however you want. It doesn't need to. It's a straight line between those 2 points, but it's not necessarily a straight line across the plot. Mm-hmm. So then she's defining her aesthetics there, and she's setting the color. So all of her lollipop sticks are going to be the color gray. She next sets her geom point, which is the end of that lollipop, that we're all used to seeing there, where it's now using those standard aesthetics. The artist is the x-axis and the rank is the y. She's setting the color to be blue, a sky blue. She's making the size of those points, size is equal to 4, so it's not a small point there, and is setting the alpha, which is the opacity or how much you can see through it, to 0.6. Mm-hmm. She's setting her theme, so the default theme that she set or is setting for this plot is theme light, so that's going to change the way that it's formatted, or viewed. Chord flip is going to rotate it, so now our x-axis is more or less our y-axis. And so this is a good way so you don't need to, if you want to flip it so it's now horizontal, what would normally be vertical, this is an easy way to do that. She's setting some additional theming parameters here where she doesn't want there to be, so element blank is telling ggplot2 that she doesn't want that element to exist. So she's setting her title, the ticks on the y-axis, the panel border, and the panel grid major, so the major lines for the y-axis, she doesn't want them to exist in her data set. So this is what makes it look like the fretboard that Patrick was referencing. She then sets these labels, so she's defining the title as the top 10 rap artists 1989, which is then she's adding the subtitle. She's saying that she doesn't want there to be an X label there, and the Y label is going to be ranking. And then she adds this additional theme FTRC, which is from the Harbor Themes package there. And so that just additionally does some more definition of the way it should behave. I don't know.
Do you need to have the theme light? I don't know that you have to have that.
Yeah, I think by actually adding this at the very end, it's like going to cancel out all the prior theming that was done. And if it has a preference for it, right? So if theme FTRC defines axis ticks Y in its theming, it'll override this. And so that might be a reason why you'd have both of these here. Is if they have different elements that they're theming, and then the order in which you apply them would matter. So she runs all that on the polls 89 data set, and hey, there you go, the first plot there.
Pretty cool.
Yeah, there you go. Looks pretty great.
1989, Public Enemy. Look at that.
Haha.
The guy with the clock on his neck. Flavor Flav, that was his name.
I wasn't around then.
Youth.
All right. So then it looks like the same sort of plot is actually being applied. Oh, no, it's a slightly different plot. But, no, it's the same plot. It's just different color and different titles. So here she's keeping all the cases where the year is 2005. With this glimpse here, we can see there's only 8 records in that year, and she throws it into the same plot. So what she could have done, if she wanted to, would have been to write a function where it allowed you to put in the data set that you wanted, the color of the point, as well as any details around the labels. And that might have been an easier way, rather than copy and paste, if she wanted to apply, which it appears as though she did, apply the same styling across in formatting across all the plots there. So you don't have to worry about, did I if I made a change in this one, I need to make sure to go and update it across the other plots if I want them to look the same. If you just write a function, you don't have to remember that because it's all being applied across them.
And we saw that in Reniere's plot in episode 3. Actually, he defined a function up front for his for what he wanted to plot, which allowed him to effectively plot a whole bunch of things rather quickly by just changing the data X and the X and the Y information. So the only thing I would say is if you're going to make a function for a Lollipop plot, you have to call the function Wonka. That has to be called Wonka.
Okay, Patrick. All right. So there we go. It's the same sort of plot, but this time it looks like we didn't have the same person ranked a couple times, and it's a few more folks in 2005. All right. So then it's the same. So now she wants to grab the most recent year, and so the way that she did that is she grabs the year column out of polls using the $, and then calls a max on it. So that returns 2019, which is last year. So that is the most recent year that they have data for. She does the same sort of filtering, keeping all the cases where year is equal to 19. Throws it into the same plot here where it's creating the Lollipop sticks based off of artists and ranking. Geome point, this time she's coloring them salmon. And then is added the title there where rap artist rankings in 2019. Subtitle, that's year she turned 30. So we can run that. All right. So then she combines them all together. And so there's a few ways you can do this, but the way that she chose it, which is quickly appearing to be a really popular way to be doing this, is using the package Patchwork, where she is defining the format to be, she wants plot.89 above, which is with that slash there, plot 05, and which is above plot 19. So,
and if you want a good overview of Patchwork, we actually did an entire episode using Patchwork. Episode 4, 2 episodes ago, was a Patchwork specific episode.
Yeah. So it's not showing really nicely in my viewer here, but we know that it turned out really nicely.
Maybe click zoom.
There.
That's
a little bit
there you
better.
go.
There we go. All right. So yeah, it's all about the spacing because it's figuring out how it should be printing it as we move it around. So, all right. Well, thank you so much, Priya, for submitting this data set, or excuse me, your code, and allowing us to explain it. I'm sure I've enjoyed explaining it, and I'm pretty sure a lot of people have learned how to do lollipop plots now. All right, so now we're going to apply the same theory of how to create lollipop plots to a new data set. Well, it's not actually new to us. It's the same data that we loaded in last week, which is the NWSLR, or from the NWSLR package, which is from, why am I spacing on her name right now? I'm so sorry.
What's that?
The creator of the NWSLR package.
Oh, the two creators of the NWSLR package, Ariel Dror.
Yes.
And then Sophia Tanner was the second person. Yeah, they're the ones that put together that package, which basically scrapes historic NWSL data, National Women's Soccer League data, since I think the league started in 2011 or something like that, 2012 maybe. So it'll scrape all the data.
Yeah, so I'm so sorry about forgetting that. All right, so we're using an R Markdown format to load it. The reason I like doing that is it allows us to have a nice little header up here, defining what the title of this project is and define the output and whatnot. And then we can just quickly jump through different sections of it as we go by using this play button here on the right-hand side. So this is just defining some knitter, which is what generates the HTML output. So we just run that. Next, we load in the libraries. We wrapped that within a suppress packages startup messages function, which is a bit of a mouthful, but what it does is it prevents all the messages that get generated from loading in the libraries from going to our console. So showing up here in the lower, in our console here, or when we generate the output as an HTML document, it'll prevent those messages from showing up there too. Because like Tidyverse has a number of messages that it'll give out when you run that, and so we don't want those. And then here we're setting the theme at the very beginning to be theme BW because we just like that theme. Sorry. All right, so let's run that. All right, so then we do some quick filtering here, some cleanup. It's not really complicated this time. We do some more munging later on. Here we're keeping all the cases where game is in 2019, so last year. Same information for stadium, and then we also are filtering the advanced team statistics to 2019. So we create the new objects: season, game grounds, and advanced ADV statistics, and those are all for 2019. So for a quick second here, I want to discuss styling that you can add to your R Markdowns, which is part of what makes them really nice. So what I'm doing here is I am creating a div, which is an HTML tag, which allows us to, we basically get a little box there. I touched a little bit on divs in episode 4, I believe, when we were discussing shinies. But when I write this in here, now it'll put the National Women's Soccer League logo at the very top of our presentation and center it in the very middle, so it looks really nice and really official. Unfortunately, when I do this, now it'll only render properly if I output an HTML document. But if I know that I'm only going to be generating an HTML document, it's a really nice way to add a little bit of personal styling to it.
Yep. And it was episode 3 for Shiny. Yep.
Sorry about that. All right. So here we start going through and doing some processing. Patrick, do you maybe want to explain this?
Yeah, so we basically take that season data frame that we created, which is all of the previous season, the 2019 season, and we're just going to create a new metric that tells us about the home points won or lost. So home points minus away points, rather. So it's the home margin. What was the home margin of victory in each game across the 2019 season? So we create that column with the mutate function. We create that into our original season data frame. And then we group by the home team in that data frame, and we create a new data frame using summarize. And what this does is it says, identify the home team and find their average home edge. On average, how much did this home team win by in the 2019 season? We do a quick little arrangement of the data frame here, descending by home edge, so the best team is on the top. And then after that, we reorder the home team column. So we do that FCT reorder. We're reordering home team by home edge. So basically ordering them by their home edge. And that's going to be for plotting purposes, as you'll see. Okay. We gotta
run it all.
Forgot to run the chunk above it. Yeah.
Oops. All right. So let's run that. All right.
Okay. Cool. And then we go ahead and we make a quick plot of this. So we're going to do the Lollipop plot. So we take that home advantage data frame, typical stuff, ggplot. I set a geom H line at 0. So basically a 0 is that your average home margin is 0. You give one and you get one kind of thing. Geom segment, Ellis went over when talking about Priya's plots. So that's basically setting the stick for the geom segment, and then we set our geom point at 12. One of the things I like about the Lollipop plots is they're sort of like cleaner versions of a bar plot to look at. So bar plots can be very big and blocky. With these types of plots, you just get that thin line and then the information that you kind of want to see right at the end of the Lollipop. One of the other interesting things about this is if you were to, say, color maybe two of the teams. So if within that geom call, for example, you did AES, color equals home advantage, pipe, filter, team equals NC or something like that, right? So if you're to do there you go, and filter, I think it's called home underscore team equals NC, right? This tends to look pretty.
Well, that's what we get for coding on the fly. I think it's probably, let's do home advantage, home team equals FC, because then it'll turn a vector of true falses.
There you go, yes. Okay.
Plot that. There we go.
It should have been fill instead of color, but yeah, there you go. So this ends up looking rather blocky. If we were to do this with our Lollipop plot, we can see firsthand. Let's go ahead and run the Lollipop plot as it is, and
so that'll be there.
Yep, you got it. And boom. Okay, that's pretty cool. And when we put the geom text, we put the actually the next line will put the actual home margin in there. That's pretty cool. Now, if you were to do the same thing in that geom point where you just called out NC, for example.
Okay, so we have to throw that into the aesthetics.
Yeah, so you need an aesthetic. Color.
No, I can just do home team because this exists.
Yes. Yeah. NC.
And delete this.
Delete the color blue. And if you rerun that stuff, this looks a little cleaner. It's a little less blocky. We could do some styling there and get rid of the legend or put the legend on the bottom or the top so there's more room. But it does look a little bit cleaner to me, at least. So I do like how these types of plots look. All right, let's go back to the original and leave it as is. Light blue, yeah. Okay, so if we run the whole thing all at once, these themes are the same types of themes that we used in the previous, in our previous screencast in episode 5, where we actually introduce the the NWSLR package. So here's the final plot. The one thing that we did add there, Ellis, you could take them through, is coloring of the background of the plot rather than leaving it as a white plot.
Yeah, so I added in this panel.background and plot.background, and I'm telling it that I want them to be fully gray. So the fill is equal to gray and the color is equal to gray. And so this will make it so that it fills out this entire background to the edge. So you can sometimes, if you run it, let's run it down to here, and then let's close off that. So see how it's all white there. This panel.background will make it gray for the most part. So it'll gray out that background there, but sometimes you want to have that full bit there. And so that's when you have to do this plot background. And then if you do fill and color, it'll color it out to the very edge. Otherwise, you get like a little white line around them, which is important for a later step.
Yep. Okay, so that's our first plot. Our second plot is maybe a team's home margin is in some way related to their attendance. And so with the game grounds data frame that we created, which is information about the stadiums in 2019, we do have information about the average number of attendance that these teams got during that season. So, yeah, there you go. Okay, we'll pull that up. And there you go, average attendance right there.
All right.
Cool. So that tells us a little bit about how many people are attending the game, and we're going to make a Lollipop plot based on that as well. So this is actually all the same theme stuff. Nothing's changed except the X and the Y variable and, of course, the data frame. But we're going to group this by attendance. We've added the same FCT relevel to relevel the team IDs to be the same order as the home advantage home team. And this will be important when we explain patchworking these plots if you were to do them side by side or something like that. But this is just to ensure that they all come out in the same order. So cool. So there we see the attendance. And this is amazing. Just glancing at it, the median attendance is probably right around, a little over 5,000. And Portland is getting about 4 times that, which is that was like insane to me. I had to recheck that. I couldn't believe it. One of the things we also could have done was normalized the average attendance to the number of available seats in the stadium, which would have been interesting to see how much they were actually filling it up. The winners in that year was North Carolina, with Chicago being the second place team. They played in the championship, and they're both right around the median value for the attendance. So despite them winning, they weren't. It doesn't seem, at least, like home field advantage was dependent on having more fans in the stadium.
All right. So now we can directly compare those using patchwork.
There you go.
So we're going to use patchwork to combine these two together. So this slash there is telling it I want edge plot listed above attendance plot. But then I'm adding this theme there. So this is the same sort of theming that we had before. But this is so the background of patchwork, once it knits these two together, then it colors the background gray as well. So it all looks like a continuous plot, which is why this plot background exists. So we're combining it, and then let's generate that total plot. And hey, would you look at that? And
so you can see the teams on the y-axis there are ordered in the exact same fashion relative to their home edge there. The reason why this was an important step at using that FCT reorder, factor reorder function, was because if we were to do something else, like, for example, change the patchwork setup and put these plots side by side, what we could then do is perhaps get rid of the y-axis on that season average attendance plot. If that was on the right, we could get rid of that, and we could have one single kind of, or two plots next to each other, but one y-axis that you could read across from left to right, and it would look really, really clean, in a really nice looking report. So having these in order allows you to do that kind of stuff.
Mm-hmm. And then just mentally, also just in this order at least, you don't have to try to mentally flip them and go, okay, Seattle was number 4. Okay, where is Seattle over here? Okay, so it makes it easier. I was debating trying to live put them side by side. I decided against that. All right.
Okay.
So then,
so after that, you kind of wanted to look at shots on goal, and in particular, shot success with kind of following up on our previous week's work in TidyX 5, making a little bit more of an animated plot.
Mm-hmm. Yeah. So this plot, Lollipop plot, is also a little bit unique because we have this ability to draw a line, and then we have normally for a Lollipop plot we have a circle at the very end there. I thought it'd be fun to put the team logos on there, so then you don't have to have this y-axis labeling. You can just see, oh, my team, you recognize their logo, and you can see it kind of moving across the entire thing there. So what I went to the sportslogos.net and downloaded all the team's logos, and it's in the repo for me right here. So I have a tribble, which is a specially formatted tibble, where I define team. So it allows you to, more visually lay out your data here. So I have team, so Washington, New Jersey, North Carolina, and then the path to the logo in my repository here. So I run that and I generate my data frame. So that's what it looks like. It's exactly what you'd expect. So then I do some manipulations here in order to get down to what I want to. So I take this advanced stats data set here, which is actually really wide. They've got a lot of statistics I'm looking forward to exploring in the future, and I subset it down to only the ones that I care about. So the team ID, which game ID it is, they have this field called total shots, which is the total number of shots taken by the team, and I rename that as shots using that nomenclature there. The shots equals total shots, and then I have goals. This game ID actually had a lot of extra information about which teams were playing and whatnot, but at the very end they had a date there. So I use regular expressions in Github to put everything that was listed is, so all characters until this dash here, and this is going to greedily quote do it until this other regular expression where it looks for cases where it's 2019 dash and then some number of characters there. So I was assuming that this was formatted in a specific way where it's the two team names dash and the date, and so then I tell it to keep only the date there. So that's how I was able to break it down into only getting the game ID. I group by the team and order it by the game ID. So the game ID is a date, and I across all the games I calculate the cumulative shots. So it cumulatively adds the shots for each game, cumulatively loads the goals and divides it by that total number of shots for each game. And then I generate this game number field, which is really the row number. So that way I can compare across all the games, because not every game was held on the same date. So I can't use game ID in order to get that information there. I use a left join to join in the tribble that I generated with the team and the logo information, but they're actually different names. So in my advanced stats data set that I've been working with, it's been team ID, but in the tribble that I generated, it was called team. And so I use this by equals, the team ID is equal to team. So that's telling it use the team ID from the original data set and use team in my team logos, and it's telling it that those are equivalent and merging across those. Finally, we have this mutate, which is then using the here package, which if you're using R projects, which we will touch on in a future episode, it then allows you to work in R projects a lot more cleanly. So this is giving it the full path to the to the logo, so that it'll work anywhere if you clone our repo. And then I'm using the same factory level to set the order of the teams so that matches the first couple plots that we have there. And then I'm removing all the cases where game number is 25 or 26, which are the championship games, so that in the tournament there. Because all teams had up to 24 games, and then there were a couple more teams that had games 25 and 26 that I then removed from this data set. So then I generated that data set. So we've got the team ID, game ID, which we don't really use, number of shots that they took that game, the number of goals that they made that game, the total number of shots that had occurred, and the total goal percentage, which is their percentage of goals that they'd made over the season, which game number it is, and then the path to the logo of their logo. So then I send shots on goal into the GG plot. The x-axis is the team ID. Y is the total number of shots taken. I use geom call here and specify the width as being fairly small. I was originally doing geom segment. In this case, this ended up being the cleanest way for it to be visualized. Now I use this geom image. So this comes from the GG image package, which allows me to use the logo as the Lollipop end. And I have to set the size to be fairly small because these original logo images are actually fairly large, and I need to scale them down to fit on my ggplot too. Then I use the geom label, which Patrick touched on earlier, which allows us to record. Here I'm listing the total goal percentage across the season with an accuracy of 0.1. So it'll list it out to like 7.1 or 11.2, and that's how far it'll show it. And then I'm offsetting it by 100 there so that it doesn't overlay the logo. I set the labels to be the same sort of things. We're ascribing data source, but we're making a GG image, a GG animate plot. So this is how I'm able to, this is some special nomenclature it'll populate my subtitle with the closest state, which in this case is the game number. I'm setting my Y limits based on the largest total number of shots, and I added 200, so I have space for my text. And this is the same theming that we had before and the same coordinate flipping. So now it's going to be moving from left to right as opposed to up and down. So I won't run this. It takes about a minute to run, but I've pre-rendered it. And so we're going to now pretend that I clicked knit because it takes a while. And I'm going to open up the file. So this is our final plot that we get to see here. So as you can see, we have the Women's Soccer League logo there planted right in the middle. They're all official-like. We have the two plots of home edge versus season average attendance patchwork together, so we can see the two there. And then we have our GIF there. And so this is in the same order as the other two plots. I thought it was interesting to see how North Carolina, like they were shooting the most throughout the entire season, but they still had a really high goal-making percentage as well across the entire season.
It's super efficient, right?
Yeah.
Look at Portland is interesting just because they didn't shoot as much, but I don't think they ever go below 10%. I mean, they didn't shoot as much as frequently, but they were very accurate in their shots, I suppose.
Yeah, they were hitting them pretty often.
And then our team down there, Seattle, it looks like that was an unfortunate year. I don't think they even hit 9% success. 9% right at the start when maybe they had like 3 shots on goal. And now then they kind of settle in. They settle in and you see their true shooting ability for the season kind of probably come to bear. I'm not sure how many shots it takes for one of the women's soccer league teams to sort of stabilize and have an idea of what their true shot percentages, but It
Yeah.
looks like Seattle had a rough season.
It does look like it.
Yeah.
And they just didn't have as many shots as some of the other teams. So,
No.
but I mean, just look at across the year. I mean, you can get some pretty high shot numbers across that. So, thank you so much for listening and watching. Hopefully you learned a little bit about lollipop plots this week.
Yep. And I'm Patrick Ward. You can find me on Twitter at OSPPatrick.
And you can find me, Ellis Hughes, on Twitter at Ellis_Hughes. Please, if you have any comments, questions, any code that you'd like us to review, feel free to reach out to us at tidy.explained@gmail.com, and we'll be sure to get back to you on that. All right. Thank you, and stay safe.